briefly, I'm gonna provide a very brief overview of operating systems, and then this is and then also first thing is the permissions. Permissions that,
That
as you
was
know,
fun.
in the Linux systems, that a lot of people, multiple users are using the same time, which means that your file should be protected by
Are you recording
protected
this?
from the reading,
All right,
protected
then
by
I'm
people
gonna
who
get
trying
off.
to read your file, right? Because, for example, if you put a very sensitive file in your
All right, bet. I
server
will.
or
I'll
the
watch this later.
computers, in this case, is you may want to
All right.
protect, right, from other people who want to really read
Okay.
your
I
the
appreciate
sensitive
it.
file, right? And then also user ID, because as
Hey,
I said, the
Ezra, what did you
Linux
put for
has
how can
multiple user
ASLR be
IDs,
defeated?
right? So one of the distinguished ways is that you're gonna operating system assign ID, unique ID to each user. So we're gonna
A
learn
brute
what's the
force
user ID and
search.
then another effective user ID. So we're gonna cover what's the difference user ID and the real user ID and the effective user ID. And then also same thing is that, for example,
Hmm.
you are given, for
Is
example,
it
I don't know what kind of
specifically an
server
infinite loop?
are you using in ECE,
Oh well, then I wrote
EECS,
that wrong.
and then so if you got a ID
I just wrote
in Linux
with
server,
brute force
EECS
check.
Linux server, and UTK Linux server, in this case, may want to change your password, right? So, so in this case, is you may want to change your password. So, but the thing is that password should be stored in a certain file.
Thanks.
Certain file, the password, the file cannot modify the other people except the root. So in this case, is we may get the root privilege temporarily, and change the file, change the password file, the change the password file where password are the stored, right? So in this case, so we there is a set UID.
Oh,
This
that
is
was
to provide
thrilling.
you temporary root privilege, and then also what kind of attack surface of a set UID are the set UID program. So we're gonna cover what kind of
Have you
attack
guys looked at the
surface and
programming
then how
assignment for this class?
adversary exploit these vulnerabilities.
No.
Okay, so what's the Linux? What is operating system? So for example, operating system is that okay, for you want to play the game, you purchase the PC for game, and then the computer is delivered to you yesterday, and then what are you supposed to do to play the game? So what do you want to do? What do you have to do first before playing game? Okay, so nobody knows that. Yeah, the getting the computer set up. So what do you do more specifically? What are you
Alright, I'm
supposed
gonna
to do?
hop off.
Okay, the computer already. Mhm.
See you guys.
Set the
See ya.
operating system to like I guess Windows or Linux or whatever.
Yes, that's true. What are you supposed to do first? The thing is that install operating system. So why do we need an install operating system? Okay, because operating system is, for example, if you want to play a game, you will play a game, maybe needed to access the GPU, utilize the GPU and RAM, CPU, and then a
Back.
lot of, a lot of devices, right? And the keyboard and the
John got
mouse. In
off.
this case, is you cannot control everything. So the reason why you install operating system, the manage the resources, hardware resources. You don't care about what resources attached to this computer. So, okay, all right. And as you said, operating system is a layer, another software also, and the layer of software to provide access to hardware, right? So, for example, hardware is a processor, for example, the memory, USB, GPU, and the storage, SSD, or hard disk, or RAM, or what else? Sound card, LAN card, wireless card, or something like that. In this case, is hardware is attached to the computer. So, but however, the program, for example, the Chrome want to access the LAN card or wireless, like wireless card. In this case is the operating system provide the channel where the Chrome or other program can access the resources. So operating system provides the abstraction of a complex hardware. So program do not need to know exact hardware, how do they operate. For example, as long as you attach a certain USB card or a certain, whatever the hardware device is, and you don't care about it. So this is all abstract, what I'm saying is abstract. You don't care about what kind of hardware is attached. And so what do you think is that as long as the driver is properly installed, so you don't care about what kind of driver, what kind of hardware was attached, hardware, what kind of hardware was are used. So the thing is that you're just using the API and then call the system call, and then you get the data from the operating system. So and also, as I said, this is a hardware is a resource, right? For example, hard disk also the share the resource, right? For example, a certain section, a certain sector are used by a certain people, but the next adjacent, sectors are used by other people. In this case, um, in this case, so operating system protect the other users to read, the others files, right? And also communications means that for example, the Chrome may need to access the certain website, and they needed to access the LAN card, right? NIC card. So this provided communication as well as security. Security is very important. Multiple users are using the same machines at the same time. So right now, I think your laptop and Linux laptops are being used by only you. However, for example, EECS, the Linux machines are being used by multiple users, right? So that's why operating system provide a security for the people who using the machines at the same time. All right, so I'm gonna give you example of a Microsoft, and then Microsoft the Windows the most, one of the representative
Hey, does your
the
recording
operating
pick up
system.
my voice?
So first time, so I don't know how many people have used the Windows the 3.1. Have you used
Testing?
the some? Have you? Nobody used it. This is a very
Interesting.
old, like 1992. I have used this, Windows 31 because when I purchased this computers comes with a Windows uh, 3.1. Oh, the Hunter have used Windows 45. Okay, 45. And then, the Windows 30.1 is released in 92. And then a program's crash, the entire operating system may crash because the many parts of the memories are shared between the program and the operating system. So this is a very interesting Windows. And then I still have a memory that I I installed program here, and then I installed the game, and then I used to play the game with this on the Windows 3.1. And then another operating system is that Windows 95, it was released in 95. This is very, when I first used this operating system, and then I was shocked because the GUI was changed a lot, and also I was really, really shocked. And then, and each program has on address space. This is kind of different. So that's why uh, so also, but the program is crashing, the entire operation system may crash because they may own their addresses, but the operation system is not unstable. So as you can see there, how the blue screen, right? So when you got errors, the blue screen is shown, and the computer will shut down, the crash area. And then the Windows XP is most people are familiar with XP, and then Windows 95 and the XP is totally different. The kernel is different. The kernel is they started using NT. NT is a very stable the kernel and the Windows kernel. That's why after this you may not face the blue screen. So the Windows XP, the 7, 8, 10. Right now we're using 10. So this is the Windows become more stable. So each program has on their memory addresses. If a program is crashed, the entire operating system is not crashed. So So one of the if the program crash, you notice that blue screen is shown to you, and then the Windows 3.1 really have the web one, but just a black screen. But however, Windows from the Windows 95 blue screen over the desk, and which means station. So if the program crash and also Windows crash, you can see the Windows blue screen, which means that your program opens to the crash. So what you have to do is to reset the computer, so reboot your computers. So okay, but when you got a message, there's the information is not helpful how to fix these problems, right? This information is um, not provided in detail. All right, and XP, and then you readily see those is Windows XP, honestly, Windows devices driver. With device driver means that when you're trying to install when you, for example, you purchase the webcam and then you plug into your computers and the drivers automatically installed. Otherwise, you may go to the Logitech and download the driver and install. So because the Windows may need to may a software is we call the drivers that those see the Windows XP. So how many people have seen the blue screen before? Have you seen a blue screen before? Okay, all right. So for example, this is an airport in an airport, and you can see that some machines using some machines using the Windows, and they have seen they if the program is crashed, they can see the blue screen in an airport. Things that I cannot really okay, so I cannot realize. So I can recall that what kind of windows being used in the airport, and then the machines, airlines for the airlines. But I can see that the airlines and the airport using very old Windows machines, and then I think I recall that I cannot recall that, but I realized that when I time like a couple years ago when I have a chance to look at their screen and the Windows very they still be using the Windows machines using very old Windows machines. For example, some ATM machines still using Windows Windows maybe XP or 9098, I guess. So because even though XP and 98 is the Windows Microsoft doesn't provide the patch, or they don't manage the Windows XP and the 95. Yeah, yeah, vending machines. Yes. So yeah, PC is still using, but right now the Windows only maintain the Windows 10 right now. Windows 7 is also suspended, so no longer maintained. So which means that even though Windows 7 has some vulnerability, and the vulnerability is found in Windows 7, but the Microsoft has no obligations to provide the patch or to fix this problem. So right. The one of the reason why they still keep using this older machine is that when they migrate to another the new machines, so they may face another problems and vulnerabilities, and then that's why they are very conservative, and they want to keep using same machine as long as they don't have problems right now, security problems right now. Okay. Okay, so as I said, let's recap the operating system, and then the operating system is that provides this is the software. It's providing more convenient, featureful the machine interfaces that provide you the communicate the drivers, and then also communicate the resource sharing, the protection, isolations. The first thing is CPU and the memory, and also clean and easy extractions, and they provide the file read and write, access and sector of a disk, right? So if you download and save the file on your hard disk. So operating system provide the interface so that you can use to read and then write file, and also provide so, uh, common services. So for example, authorizations, and for example, you want to access the Linux machines that you know um, they prompt you. These machines prompt the operating system prompt you the password. As long as you put the proper password into system, you can authorize that you can use the Linux system. All right, and then the security job of an operating system is that first thing is to control the access to resource, right? And then the second thing is ensure integrity of the resource. And then the third thing is that the security generate, and then another thing is that the operating system generally underpins the security software running the operating system. So which means that as long as the operating system, for example, soft, drivers, if we have vulnerabilities, which means that the operating system also becomes, vulnerable as well. So that's why the software is running operating system is very important, uh, and then also software in the running an operating system should be should be secure. So to make operating system secure. Okay, so the resource that operating system manages, as I said, the memory, so the storage, and CPU, and the network access, like NIC, wireless NIC, and something like that. And also operating system provide general behaviors, reading and writing executions. For example, if you're using Chrome, and the Chrome may access the NIC. NIC is the network interface, and then trying to access the internet, for example, gmail.com, and then you may download the attached file from the hard disk, and the Chrome trying to write a attachment on the hard disk. And in this case, they may the Chrome trying to access the hard disk and through the operating systems. All right, protected stories. So as you have seen so far, some multiple users being used, multiple users are same time using the same operating system, like for example, user one, user two, user three, using the same program, maybe different programs, and the same the machines at the same time. So what are you supposed to do? So for the in terms of security, what are you supposed to do? What kind of things need Windows or the Linux like operating system provide? The first thing the first thing is file permissions, right? The file permission means that, for example, you are using because you're on the laptop and the desktop, you don't care about the permissions of a file. However, if you download very sensitive information, the file that have very sensitive information, social security number or tax report or medical history or something like that, you may in this case is where you need to download those files, save those files, the Linux server in the EECS department. In this case, is you don't want to share this file with other people, right? So for achieve this kind of goal, the Linux provide the file permissions, which is that as long as there is some permissions, you can specifically set the permission with the file, and then you want that you can share the file or you cannot share the file, something like that. So files in the modern operating systems or Linux have a set of permission bits. So you're gonna learn what the permission bits here. So also, this is a permission control the user's ability to read, write, and execution. So we call each of these behavior is a capability. Sorry, capability. It's a capability, and then the user means here that you really use there are three things. The first, me and the file owners, and the second thing is group, the group that I belong to, and the third other people. So there's a three, the three, the there's a permissions have a three things. So me and the group, and then the other people. All right, so okay. And then there's a two things. So there are two things control that they have a two mechanisms for the permissions. The first thing is user-based access controls. The capabilities are bound to particular users. So for example, particular users can access those files. Another users cannot access this file. And then the third is the role-based access control is the capability are bound to the collection of the users that have a particular need to based on the expected task. For example, you are students that have kind of role, and then you're supposed to do something. For example, TA is supposed that they have, for example, the Canvas is that TA has access to certain the menu and then quizzes your score and something like that. And this is role based. However, other people, other your colleague in the same classes cannot access your grade, right? This is a role based access control. And then, so let's take a look at the Linux permissions, because our operating system, we mainly focusing on the Linux. So that's why we look at the Linux. The Linux permissions can be viewed as ls, the L with the option with the L. So I think most people have used the ls, so you may know what ls means, right? Ls means they print to, the print the list of a file, and then the option L is that the permissions and also date, the creation time and the modified date and something like that. All right, so also you can change the permissions with this command, change the mode and the chmod, and then I think you already know how to use it, right? And then the permission mask represented by integers. So you're gonna learn what it is in the next slide. And it can be set for different subject. As I said, me, my file owners. Second thing is group, where the group that I belong to. And third thing is like other people. Or as I said, file owners, the file groups owners, the group I belong to, and then everyone's other people. This is the three different subject. And then so your permission level is determined by checking in that order. So first thing is owner, group, and anyone else. So first one you match to your group is applied. So first they're gonna check the first owner. Are you owner of this file? And then Linux, check that this group is are you belong to, and then otherwise you are other people. They consider you other people. You belong to these two first things. Okay, this is a permission bit, right? As I said, the Linux permission mask represented by integer, which means the has certain integers. So you can see that the bit is that there is a three the three symbolic mode here. So for example, RWX, and RWX means the R is a read and the W is a write, and then X is execute. So as you know, R is read. Read is that the file you can read, and the write is that the file you can write. And X is the, for example, for example, the file is binary, like for example, is the binary or program code, and then the permission is required to execute a file. So if you don't have a X in the permission, you cannot execute a file. So you may want to change the mode. You may want to add you may want to add more permission, like execute permissions, and then you can execute a binary. So, and the represent is a 2 to the 2, 2 to the 1, and 2 to the 0. So which means then 4 to 1. So, and then they're gonna the integers are sum, so that's why 7 here, 4 to 1, because 2 to the 2 and 2 to the 1 and 2 to the 0. So the 1, 1, 2, 4, and then total is a 7, right? This is this is a binary, okay? and then is a 2 to the 2, 2 to the 1, and 2 to the is a 0, 2 to the 1 is 0, 2 to the 0 is the 1 here. So it's a total 5. And then 2 to the 2 to the 2 and 2 to the 0, 2 to the 1, and then it's a 5. For example, 1, 0, 0, and say 2 to the 2, and then it becomes a 4. So here is a 5, 7, 5, 5, and then, for example, a certain file, if you set the permission of this file is a 5, 7, 7, which means that you can write, you can read, you can write, you can execute, and if you groups that belong to like a graduate students or undergraduate students or senior, for example, in this case, other people who are belong to the same group can read your file and also execute it. However, other people who belong to your same group not able to write this file because the write permission is disabled. Also, other people who not belong to the same group, and then they have only permissions to read and execute. Okay, and then the other people can write this file. Right? This is simple, right? So, but however, directory is kind of different. This is previously this is only for file. The directory is that R is the ability to read the contents of a directory, and then write is also, as you presumably, I also as you assume that is write a file into the directory, like the file directory into the directory. So create, rename, delete the file and directory with the same directory. So X means the ability to enter the directory, like for example CD. So this is a file and the directory have different permissions. Okay, I'm gonna show you the demonstrations that I made. Give me 1 minute to reboot my virtual machines and then I can share the. Okay, let's see. Okay, can you see my virtual machines?
Yes.
All right. So here is so I created a very important directory, right? So and then here's thing is that directory, right? And then the code is 7, 0, and 1, right? And then the owner of this directory is a root, and the group of the permission group of this directory is a root, and then when the directory is created, right? So okay, I'm gonna change it to like for example 700, which means that only 700 means that only the owner can access the directory, right? Okay, and if I ls a very important directory, how do you see that? Can one guess? Can anyone guess what happens if I type like this?
If you're not
Anyone?
root, you won't be able to see it.
Yes, exactly. Because as you can see that this is a 7000 because this is root, right? So I'm not root, right? I am COCS 3066, right? All right, so which means that I'm not belong to these users. I'm not this user. I'm not belong to this group, and then I'm others, but others is 0, means that I don't have any permission with this folder. Okay, so how about very important 704 read. So here is then 700, 0, and 4. So what happened to if can anyone guess what happened if I type ls here?
You can view it, but you can't CD into it.
Oh, do you think I can see the file inside?
Yes.
Okay. Yes. but I can see the two files, right? I can see the two files, which means that, as I said, that there's a two files inside f.txt, and there's a template folder inside. However, permission denied. However, I can see the list of the temporary. However, if I type here, if I edit LL the options here, I can see the read the permissions. I can see the creation time. I can see the what kind of permission bit, and what can see. I cannot see the owner of the group owners of this file and the directory. Okay. All right. So, and then I just, what if I can see the? Can I see this file? If I type the list?
No.
No, we cannot, because I'm going to explain later why you cannot see this file. Okay, so and then how about this then? So we can write this file, for example, AES. As you guess, we cannot write the file because we don't have a write permissions, right? Right, we don't have permissions to write. As I said, it's a 400, right? So we don't have a permission to write. So however, how about this? So for example, if I add, so in this case, so I have only executed the permission, executed permissions that enter the directory, right? Right. So if I, what if I can type here, can you read this file directory? Can you read this directory? Okay, it's a permission denied. However, we can go into inside. It's also permission denied, right? So we can see that X permissions, so provide us to enter the directory. However, we cannot read this. Ls R is required to read the file. Okay. All right, and then so for example, however, how about this one? So cat f.txt. Can you read this file? Cat is the the print the read this file. So just for your information. Okay, we can read this file. Okay, so are you sure that is a F have a permission is a 644 something like that? It is a root to privilege before I should so that sorry about that. So which means that as long as we have X permissions, which means that we go to the CD, but however we cannot read the contents of directory, the list of file. However, as long as we know exact name of the file, we can read the file. So, all right, and then so for example, okay, and then 700, okay, and it becomes 705. So if we go to, you can see that we can read this directory and also files, and we allowed to ls here, we can read this directory, right? And then this is kind of different from directory and the files, and the permission a little bit different. So because the directory permission, because some people make confusion, what do you mean by executions in a directory? So so directory means that ability to enter the directory. Okay. All right, let's go back to as you okay, let's last try is that as you guys if we want to try here, and that I cannot because write is disabled, I cannot write any files here, right? So and also make a directory A is D9 as well. All right. All right, let's go back the slide. So as I said, is a directory have a different, kind of a little bit different. So for example, executions. For example, the binary as you know, the binary is the execution of a binary is the executing the binary. However, the directory kind of a bit different. Maybe sometimes confusing, but you know. All right, this is a permission example. The first thing is that there's two files. The full bar is owned by Bob, and the his group is graduate students. And then with the permission is a 754, and then another file is a hello world, and owned by Alice, and Alice group is graduate students, and the permission is a 705. So the users, LDs, and the graduate students trying to access the full bar, and what happened? Can also anyone know how what? Okay, so Alice can access a full bar, or can access a hello world. So okay, let's look at the full bar. So Alice can access a full bar file. Can you read?
Doesn't she have read and execute access to the group, which is
Yes, right. So she can read the file, she can write the file because they belong to the same groups, right? How about the hello world?
Are you asking if Alice can access it?
Yes, still Alice. Still Alice is a hello world.
Doesn't she own the file?
But she can do everything to it, right?
Yeah, that's right. The 7 here. This is owner. They're gonna check the first owner in the group and the others, right? She is the owner of this file, and then she can access this file, read, write, and execute it. How about the Bob? Bob, as you can see that this is the owner of this file. They can do read, write, execute, right? And how about the hello world? Hello world. So Bob can access this file, can write, can read, can execute this file. The Bob
Only
can
read and execute.
read and execute. Yeah, right. Because even those same groups, right. Let me see. It's confusing.
Because of the 5 from the other. So no group is blocked, it would default to other.
Yes, that's true.
Which
that's
is
right.
missed.
Yeah, right. So Bob can read and write, can read and write because the others people, the Bob is considered as other people, right? So that's why they have a permission read and write. And Charlie in this case is their group they belong to the same group, and then they're gonna have the same permissions, so read and write. And then also here is the same group but the 0, which means that but in the group don't have it, but other people has read and write, and then Charlie can do that. And then also Dave, Dave not belong to this one, and Dave is considered as other people, and then he cannot he is able to read this file only. So, and then also undergraduate students, and he's all belong to undergraduate students, and then the group is different, and then David is considered as other people. And then also here is that David is also not belong to this group, and then also he will have read and write permissions. Okay, the permission is kind of funny though. And let's take a look at user ID and effective user ID. Okay, so as I said before, the multiple users, in operating system, user A, user 2, and user 3. So how can we distinguish them? So how can we identify them? So first thing you can do is assign a unique number to each user ID and the user. So we call the user ID. So a number is assigned by the Linux to each users on the system, and the user to identify users, the system, and determine which the system resources users can access. So the Unix, like the operating system, identify users by the value called by user ID. User identifiers are identity groups are by group identifier GID, and then user ID is a UID, and are used to determine which system resources a user or group can access. However, there's a special users, the root. You may know what is a root, right? Root is users of Linux box have access to anything, right? So as long as you have root privilege, so you can access all the file, you can delete, you can write, you can execute all the file, you can control, you can be a how can I say, you can be a like God on a certain system, so you can control everything. So for example, if you can remove all the file, and some people in the chat, I'm gonna give you. So for example, if you root type like this way, which means that all the file will be removed. So some people who may forgot he or she has a root privilege, and they're trying to this menu, remove all the file, and then all the system is removed. So when you're using the root, when you have a root privilege, be careful because you're gonna have a superpower. So, and also the Windows has a similar concept with the administrators and system account as well. So, and then the user's ID of root is always 0. All right, so let's take a look at and where the UID are stored. So the user UID is stored in the etc, and then in the password file they have user ID and the username, and sorry that user the ID, literally ID, and the UID, and then some information is stored in this file. And then traditionally, Unix system keep the user account information, including one-way hash the password in a text file, stored in a text file with the code, password pass WD in a password, as a file is used by many tools. So for example, the LS to display file ownership, and by matching the user IDs with usernames, and the file needed to be word readable. So there, as a result, can be somewhat of a security risk, right? This is traditionally all the all users informations, encrypt the password, hash of the password, stored in the text file. However, this is text file can be read by other people, even though the password is encrypted. Can be leaked, some informations, and it can be lead to another vulnerability. That's why right now the password is stored in the a text file. The shadow is only readable by only root. So of course the passwords are encrypted. So right. So if you see that, so right now the thing is that your user information is still stored in the password file. However, your real password is stored in the shadow in the file. But the shadow you cannot read as long as you don't have the root privilege. Only root can read this file. All right, so I'm gonna show you that. So let's go back to the okay. All right, so here is that. Okay, the cat. So the password has the user root 0, right? 0, and then so I'm gonna explain later what kind of information is stored here, right? Though, and then my ID is a COSC. This 366. My ID is 1000, and then something like that. My home directory and bash default bash. So here all the information. There's no password stored here. So um, when I trying to see the shadow, so when I see the shadow, the file shadow, that contain password, I cannot see that. So if I have root privilege, so I can see that. Oops. And then you can see that my password and ID and the encrypted password and the store here and some other information in here. So the password is stored in a different file, right? Abstractionally, all the passwords stored in the password right now, they moved to they were moved to shadow file, right? Let's go back to slide. All right, so as you can see that there is an example, the password, there's a root, this is a user ID always 0, and they being like that, and then this is a user ID, and this is supposed to be password is removed, right? And the user ID, then GID, group ID, and then also user information, home directory, and then also shell. So kind of what's the default shell? So when you're trying to log in, and the first shell was executed. That's why all the information, you know, um, all the information that you need when you log in is stored here. Okay, and then let's look at when the okay, let's take a look at the shadow, and the shadow. If you see the shadow, you can see the root and the password stored here. And then if you can look at the each line in detail, and the first thing, user ID, include the password, and then the minimum days and the maximum days, 1 days, and how long user can be activated, and then also inactivate days, and then display disable days, something like that. So all the very sensitive information is stored in a shadow, and then very common information, the not sensitive information stored in password. So here, all right. Okay, so let's take a look at set UID, because we have seen the group ID and then user ID, right? So you're going to look at the set UID. So you may wonder what is a set UID and why we need a set UID. So for example, so let's assume that. So for example, you are admit to the ECS, and then you are assigned account. You gotta give an account from EECS Linux machines, right? And then they're gonna assign the machines, assign the ID and the password is very simple. Like for example, AESDF, and then you are asked to change the password, right? So, and then you may want to type password, and the password, this is a key, this is a command, enables you to change the password. So right. So there is a dilemma, right? Dilemma is that permission over a shadow file is only root, right? Only root can change it. So if I change my password, which means that my password, change the password, encrypt the password, should be stored in the shadow file, right? So how can normal users change their password? So can you? So which means that, okay, repeat again. So this shadow file has only root can access this file, and then you can see that read, write, no execute, and the read, and other people can write, can read. So however, change the password, which means that new password should be written to um, the shadow file. So which means that write permission required for typical users. So which means that, so if you enable write permission, see here, for other people, because we are other people, we are not root, right? So if we put a W here, which means that other people can write, and then which means that I can change, Hunter's password, I can change Noah's password, right? Right, even though I'm not root privileged, if I have root write permissions, right? So this is kind of password dilemma. So the typical you just want to change the password, so which requires the write permissions shadow file. However, I don't have root privilege. So what we can do? So for this one, the Linux, the people who working on Linux systems come up with a very interesting idea, which is that set UID. Send UID is that program, send UID program, send UID, and then also password is one of the send UID program. Is a widely used Linux Unix system, and then also the program marked with a special bit. So you can see that. So for example, one of the example, let's see. So here is that, for example, said if you type the password and then ask your current Unix password, you can see that if you are a real user of this certain the HP, for example, they're gonna check are you real the HP, and then you could type a new password here, and then if you type the password here, correct the password, and you got the root privilege temporary, very short time, and then you're gonna type here, and the password is stored. When your new password is stored in the shadow file, the password file has temporary the root privilege to write the file. So what you can do is that, what if we can expose kind of exploit the vulnerability of this file if you temporarily get the root privilege, which means that you can control the system, right? So we're gonna look at what kind of attack surface of set UID programs. Anyway, so the set UID concept is that allow users to run program with the program owner's privilege, and then also allow users to run programs with a temporary elevated privilege. So you program has temporary got the root privilege, very short time, and then after returning to the program, and the root privilege will be gone. So the example is a password. So as I said, is for your password. The password is that there is a special the bit here, and there is a root privilege, and when you type it, and they're gonna give you a very temporarily the root privilege. So let's look at take a look at the concept. So every processor have a two user ID. First thing is the real user ID. So real user ID is, as I said, root 2 is 0, and then my COSC 366 is my ID was 1000. So this is a real user ID, and the effective user ID is identify root privilege with the process, and then the access control is based on the effective the UID, EUID, effective user ID. So when a normal user executes, so RUID and EUID is equal, and then they both equal to user ID and ID of users who runs program. So effective user ID becomes RUID. Okay. However, when the set UID executed, the RUID and then UID is not the same. So UID is never changed if you got a account. For example, my ID in my Linux machine is UID. RUID is that 1000. However, if I run the password and effective ID is 0, and then as I said, RUID still equal to UID. However, equal to the program owners like a root. Right? For example, the password, the UID is RUID is 1000. However, when I execute this file, effective UID is become 0. So which means that when I execute the file, I temporarily obtain the root privilege for a very short time. All right. All right. So as I said, the program is owned by root, the program runs with root privilege. So if you expose kind of vulnerabilities program, so we may obtain the root privilege. We're gonna take a look at later though. That's a slide. Okay, this is a example. So turn the program into the set UID. So here is that the cat. Cat is the as you know, cat is the read the file, right? So copy cat to my cat. So my cat is just cat. Just copy this file, and it has the same capabilities, right? And also sudo change on the root my cat. They're gonna change the owner of my cat to root, and then so you can see the root here, and then my cat, the permission. No, sorry, the owner of my cat is now root. Okay, and then if I run this code, permission denied. Of course, because I don't have. Let's see. Because I don't have permissions to execute file. So this is permission denied. Okay. However, so if I change the 4775 my cat, and then this is a 4 missing send UI this special bit. So my cat, and if I run the my cat, you can see the shadow file, because the reason is that I have temporary had root privilege, and the root privilege enable us to read this file. So you can see that. So if you enable set UID, and then as long as we and then we can run this file with the set UID, and we can read the file that is, and then after we obtain the root privilege. So how it works, the set your program is just like other program, except that it has a special marking. So which is a single bit called set UID. You can see that. Okay, so for example, there's no UID shown here. However, if I added 4 special bit here, you can see the EUID here. So EUID is root, and then if you run this code, and you can see that if you code, you can get the root privilege. All right, so another say UID example is that still the copy and the shadow is denied, right? So okay, and then the same thing, right? If I if you enable the set UID, and then you can run, you can read the shadow, right? And then also, however, if you change the owner of the my cat, and like a seed is a user ID here, and then if we change the 4755 of my cat, and then my cat cannot read this file, because the cat the seed doesn't have rootability, and then also accordingly the seed cannot read a shadow file. Shadow file only readable by the only root. Okay, and then let's take a look. So let's see if I could finish this one. Okay, so this is a security class, right? So set UID looks perfect. However, set UID become the vulnerable, and then adversary can exploit, right? So this is a typically, although normally you just escalate, root privilege. However, and also restrict behavior, because you are given a very root privilege a very short time. However, it's unsafe to run all the programming to set UID. For example, the shell means that as long as you got the permission to run shell with the set UID, and then you got the root. You got a shell is executed with a root privilege, and you become root, you can control all the system, and so VI also taking execute command line, and the command line able us adversary to to behave very unnecessary behavior, right? For example, adversarial behavior, like for example, remove and read sensitive information, other sensitive information, like that. Okay, so we're gonna take a look at the attack surface of a set UID, because usually input and the system input and the environment variable is provided users, right? So that's why adversary becomes users become adversary, and the users can exploit the system, and the users can compromise the systems, right? So we're gonna take a look at how adversary exploit vulnerable set UID, how they found what kind of attack surface of set UID programs, and how they exploit vulnerable set UID programs. Okay, in the next Tuesday. All right. Okay, and see you on Tuesday.